You mean to tell me that the noisy data from the last video that looked like this could lead to a classification report like this, where the accuracy is 100%, my precision and recall are excellent, and I have an excellent F1 score. Moreover, I actually want to demonstrate how I can take this data and generate a PLS scores plot with two perfectly resolved clusters, one representing the hardwood and the other representing the vinyl flooring. Recall in the last video I demonstrated how I went to Home Depot one day when I was feeling nerdy, and I took a portable infrared spectrophotometer with me to the store. And while crouched in the shelves, I went to the vinyl flooring section to sample several different qualities of vinyl flooring. And then I went to the lumber yard where I sampled several different types of lumber, such as pine, oak, and fir. Also in that video, I said a tree is different from a water bottle as it is the wood is from vinyl flooring. And I actually do have a water bottle that I will test in this video and demonstrate where that will land on our scores plot, as well as my door and a Pyrex container, all for different points of reference in this model. When it comes to building a data model, you need to pre-process this data, and Python has several techniques to allow me to pre-process my spectroscopy data. So I generated a pipeline first with standard normal variant, or SNV, to help me reduce the scatter. I then used squiggly for smoothing and some baseline correction, especially with a first derivative filter applied to this algorithm. Next, I z-scaled my data to help reduce any of the bias that might come from some of the more intense peaks and allow the model to stand a better chance at finding the significant features for building this model. Next, I used partially squared, or PLS, not as the final step in my data pipeline, but also as a pre-processing step to help reduce some of the variables before passing into a logistic regression model for classification. Now, although that might seem like a lot of steps, Python makes that very easy to implement. Here is that pipeline illustrated in code where I have my SNV step, my squiggly, z-scaling, partially squared, and logistic regression. And so with this, I can easily build my model and then test that model using train test split, as well as adding new validation samples that I expect to either go with the hardwood class or the vinyl class. So before I show you the results, if you had a spectrometer like this, what type of samples would you look at? Now, I do plan to look at a tree in the next video, but what would you test with a device like this? And maybe I'll use it as an idea for a future video. With those steps, here is that classification report again, where I have my precision and recall of a 1, my F1 score of 1, and the support just tells me the number of samples per class. And then here is my accuracy value at 100%. Rather than just showing you the data as a numerical output, I also wanted to include this PLS step to allow me to visualize what the model is doing to help you gain some intuition of how powerful this technique is. Here is a quick view of how I'm going to generate this data. I'm going to make a plot for my training data. I'm also going to add another layer to that plot with my test samples. So these are the samples that were applied to the model after the model was fit, just so we can see how well they classify. And then I'm going to add 2 more figures on top for the validation data that I'll show you later in this video. Now I'm illustrating what that training and test data looks like. In the circles are my training data. So the blue circle is the vinyl sample and the red circles are the real wood. And we can see how well those two clusters separate in this PLS model. We have on the left side all of our wood samples, and on the right side we have all of our vinyl samples, and the diamonds are the test sets. So these are the samples that were then added to the model after it was fit to see how well this model performs. And these samples are very similar to the training set. And so I wanted to add a validation set of data that does not look like the wood samples from the store, but also kind of add more variability to the model for better testing. In order to do that, I wanted to just test my door really quickly. I know my door looks like hardwood, although I'm not any sort of handyman, but I thought it would be a good way to test if this should fall into my wood category or my vinyl category. So I'm going to uncomment these lines and then illustrate what that looks like in the figure. Now we can see that this figure has been updated with a new set of gray samples here. And those gray samples represent my wooden door. And it's nice that although this is slightly removed from the red samples, it's clearly closer to the wood samples than to the vinyl samples. And so as this sample is pushed through the model, it's getting classified as a wood sample, and we can see that visually. So now let's see what happens if we test something like this water bottle or this Pyrex lid, which is some sort of plastic material. To do this, I don't need to retrain the model. I just apply the pipeline that was already fit on the training data to these new samples and rerun. So that's all I'm going to do here is include a new scatter plot with my validation samples, and they're going to be colored to match their new identities. Let me run the cell and let's look at our updated figure. Now the wood door is just illustrated as purple, but my water bottle and Pyrex lid are showing clearly on the plastic side or the vinyl side. And so we can say that a plastic bottle is as different from a tree as is this hardwood is from the vinyl flooring. And we can see that really easily with this data. So with a small device like this, we can already collect a lot of real world data. With data pipelines and Python, we can easily automate the data processing. And now I'm going to ask you, what other samples would you like me to look at that might fit this pipeline? Or we can actually build other tools for determining, let's say we have genuine leather or vinyl plastic there as well. In any case, I'll see you in the next video. Peace.